They move among us, but have powers we can scarcely imagine. They are the natural world's finest hunters. One uses heat. One hunts with sound. And one uses the power of electricity. 3 extrasensory predators. But what are the secrets behind their powers?
It's like a scalpel. You don't even feel it at first.
I have to watch this all night.
To understand how these animals work, we've built detailed virtual models of their bodies using the latest scientific data. With them, we'll venture deep inside these creatures to find out what gives them their extraordinary powers. Join me as we embark upon a quest to unravel the mysteries behind animal superpowers. There are creatures on this planet that have evolved strange senses to hunt their prey. These extrasensory powers give them the edge in a dangerous world where it's kill or be killed. Take the hammerhead shark. This strange-looking animal possesses an equally strange superpower. An extra sense that gives them a formidable advantage in the hunt for prey, and might even help them navigate across vast oceans. Hammerheads are voracious predators, capable of eating large fish and even other sharks. But much about the lives of these remarkable animals is still shrouded in mystery. What we do know is that they see the world very differently to us humans. To find out more, we must travel to the Florida Keys, where one scientist is turning the tables and hunting the hunters.
So we're down here in the Florida Keys, and we're motoring over to a habitat that's very rich with potential prey items, which are a large number of wild sharks.
Marine biologist Steve Kaijura studies how sharks see the world. Today, he's fishing for hammerheads.
One of the big advantages of being here in Florida is that we are able to run down to the Keys anytime we want to get a large number of wild sharks. What I like to do with these sharks is bring them back to the lab and run some experiments on them. And the advantage there is that these are naive animals. They've never been in captivity. They've never been subjected to any sort of conditioning at all. We're able to get a natural response from these sharks, just as they would respond out in the wild. So we're just in the process of setting a gill net here, and this is a net running between the boat and the mangroves over there. It's amazing. They're little sharks as babies, as pups, but they have extremely sharp teeth. And it's like a scalpel. You don't even feel it at first. And then you look down, you see all these parallel blood marks all over your fingers and thumbs where they've gotten you and slashed across.
These warm, prey-rich waters are perfect hunting grounds for young sharks. It's not long before they spot one.
Splash in the water right near the end there.
The shark is a young male bonnethead. It's the smallest of the 9 species of hammerhead, making it easy to handle and a perfect subject for Steve's tests.
We just caught a bonnet. We deliberately have the shark upside down. This enables it to go into a state called tonic immobility. It's kind of like a trance-like state. The shark just sort of lies there and relaxes. It makes it much easier for us to transport them, less stressful for the animal.
To investigate the extra sense that makes hammerheads so special, Steve needs to get this shark back to the lab as soon as possible.
It can't swim. It can't swim around in that tank. So we need to get it back into a large holding tank where it is able to swim freely.
This shark is most vulnerable when it's out of the water. Steve must move quickly.
Oh, I'm ecstatic. This is great. It's so good to grab a shark and be able to bring it back and throw it in the tank and have it swim so well right away without having to have any sort of revival. That's the real trick with this, is getting the sharks back right away before they have a chance to stress too much.
In the bright light and clear water of the lagoon, the hammerhead can spot prey using its superb vision. But surprisingly, they rarely hunt during the day.
The sun is setting. It's getting to be dusk, and a lot of the sharks are going to be out hunting. They tend to be generally more active from dusk until dawn, searching, hunting for prey. Whereas vision is important, well, it doesn't really do you much good at night when it's dark out.
There is a way to find prey, even in the pitch black. In salt water, every living creature generates a weak electric current. And because water conducts electricity, the current flows away from the animal into the sea. It surrounds each living creature with an electric field, a glowing halo not visible with normal sight. But these fields are extremely weak, 1 million times less powerful than those generated by a household light bulb. Sensing them at all is a real challenge. Steve is convinced hammerheads locate prey by sensing these minute electric fields. And he's set up an ingenious experiment to prove it.
So what I'm going to do is place this acrylic plate on the bottom of the pond here. The acrylic plate has 2 circles on it, one here and one here, and those are actually lead via these underwater cables that are going to plug in here up to a stimulator box. This stimulator box has a battery in it, and what I'll be doing is producing a very weak electric current that flows across here, and that sets up an electric field that the shark will think is a type of prey item, like a little crab or fish or something, and come in and bite at it.
By making the current bigger and smaller, Steve can test how sensitive the hammerhead's electrosense is.
So I'm turning on the electric current now. I can see that there's 20 microamps of current passed across the electrodes over there.
At first, the sharks don't seem interested. But that changes when they get in range.
There, bonnet, biting at the electrode. Clearly biting at electrode 1, coming back, biting again, and off, and switching, and electrode 1 on again. There, good biting. Exactly what we expected to see. The shark's attracted to the electric stimulus.
Experiments like this prove that hammerhead sharks can detect the weak electric fields that surround all living things underwater.
Sharks have the most sensitive electrosensory system, able to detect electric fields down in the range of a few billionths of a volt per centimeter, tiny little voltage gradients.
This is a genuine sixth sense. It's made possible by strange structures clearly visible beneath the shark's head.
If you look carefully on the tip of the snout, you can see all these little black pores all over the surface of the head. Those are all the electroreceptors.
To understand how these pores work, we have to take a closer look at the shark's hammer-shaped head. Each pore is lined with cells that are sensitive enough to detect the tiniest electric current. The pores are highly directional, with a range of 1.5 meters. They act like invisible whiskers, allowing the hammerhead to pinpoint exactly where its prey is, even in total darkness.
This extraordinary power gives hammerheads a killer advantage when hunting at night.
But hammerheads don't just use their electrosense to hunt.
172 Pop Kilo, request 500 feet.
Steve has been surveying shark numbers off the Florida coast all year, using a camera mounted on his aircraft. In the summer, they're here in their thousands. Each of these black dots is a hammerhead shark. But in winter, he finds very few. And that means the sharks are on the move, some migrating thousands of kilometers over the course of a year.
It's critical that they're able to find food, find mates, and do that consistently year after year. And so if you were to not have the ability to home in and come back to an area that you knew was populated by a lot of other members of the same species, then you wouldn't be very productive, very successful as a species.
For any sea creature, navigating underwater is a major challenge. The oceans are vast, and visibility is poor.
How are organisms able to migrate and make these huge long-distance migrations without any clear visual cues, any other way to keep track of where they are?
On these epic underwater journeys, we think the hammerhead is guided by its superpower.
Underneath the surface of the sea lie the vast valleys and mountains of the ocean floor.
These huge geological features would make perfect signposts for ocean dwellers navigating the seas. But at these depths, there's no light to see them by. So hammerhead sharks have evolved a unique way to navigate in the dark. Some of the rocks on the ocean floor have a distinct magnetic signature. Even though hammerheads can't see these rocks with their eyes, we think they can sense them with their electroreceptors.
For the hammerhead, this turns the ocean floor into a map with distinct landmarks and even highways. This super sense makes hammerheads master navigators capable of migrating
Thousands of kilometers without losing their way. Armed with this sophisticated electromagnetic supersense, these sharks make formidable predators.
If you look at the whole of the animal kingdom, there are really very few species that we know of that have the ability to detect electric fields in their environment. So in that sense, you could say that the organisms who have this electrosense, it really provides them with some sort of superpower compared to other fishes and other organisms that simply don't have it. So I've been studying hammerheads for, over a decade now, and I'm still not done. There are still a lot more questions that need to be addressed, so I think that I'm going to be studying hammerheads for quite a while longer yet.
The hammerhead's ability to sense electricity has given it a huge advantage as an ocean predator. It's a unique superpower that works well underwater, but not on dry land. Animals that have left the sea need a different strategy.
Some snakes have evolved a unique form of supersight that allows them to hunt when conventional vision is useless. Even in the pitch black, they manage to strike with pinpoint accuracy. This super sense allows them to thrive everywhere from the deserts of America to the jungles of Burma.
For prey, there's simply no escape. Because these snakes can sense the heat of the blood that pumps through their victims' veins.
To find out more about this remarkable ability, we must return to one of America's most snake-infested states.
Florida.
It's back in the back corner there.
All right, let's see what we got. Good size one.
50 species of snake live in Florida.
It sounds like a bad horror movie. Snakes are eating Florida.
Some are venomous enough to kill humans with a single bite.
And the problem is, these pythons are eating just about anything they can wrap themselves around.
And it can grow into this as quickly as 3 or 4 years.
They're not just out in the wilderness. They're in people's backyards, too.
If I can do him with the hook, it'll keep him calmer. They will stand their ground.
Some have a super sense that makes them deadlier still, even for the experts. They can see heat.
They can sense where your hand is. They can bite through the bags. Even the breath from a human that puts off enough heat for these animals to detect it.
These snakes can make an accurate strike from inside a dark bag, thanks to their ability to sense tiny differences in temperature. Deep in the Florida wetlands, one man is on a mission to understand more about this incredible ability. Biologist and snake enthusiast, Michael Grace.
This is an amazingly rich environment. It's a great place for all sorts of predators, but especially snakes. But the pythons that live out here have something very special. They're one of 2 groups of snakes that have a special sense that's not possessed by any other organism on the face of this planet.
Michael plans a groundbreaking experiment that should provide never-before-seen footage of a snake using this special sense. First, he needs to catch a wild snake.
This is a great place to find snakes, but you have to find a good hiding spot. They do like to hide. People sometimes ask me how I go about catching snakes. The short answer usually is very carefully. Non-venomous snakes, not too big a deal. They have lots of teeth, 4 rows on top, 2 rows on the bottom, and they're usually recurved, and sometimes they're very long. So it's not fun to be bitten. But generally, I pin them down if I have a snake hook, or if you don't have a snake hook, you just go find the nearest branch from a tree. If you ever have to pin one down and get it behind the head, though, that's where care really comes in. Oh, here's a good sight. Oh, there's one over here. We have something. This is great. This is a Burmese python, native to Southeast Asia. All in the news these days. People say it's taking over South Florida. That's a nice one. What a beauty. We'll take this one back and we'll try some experiments tonight. We'll show what makes this animal such a perfect killing machine.
The Burmese python grows up to 7 meters long. It can kill and devour prey as large as deer. To attack, the python bites prey with needle-like teeth, then squeezes the life out of its victim. Even in the dark, it strikes with lethal accuracy, guided by the heat of warm-blooded prey. Michael needs complete darkness for his experiment. His home for the next 6 hours is a specially constructed field lab. He's setting up a unique high-speed video camera that responds to heat instead of light. All warm objects constantly emit heat in the form of infrared radiation. The camera senses this infrared in amazing detail. It means Michael can record the snake's movement in total darkness.
This camera is really useful for us here tonight because it allows us to see basically what the snake is seeing. We are looking through a snake's eyes when we use this infrared sensitive camera.
The goal of this experiment is to see whether the snake can sense a warm object in the pitch black. The target is a black balloon filled with warm water. To the snake, it should look like a warm-blooded mouse or a small rat.
And we'll have that balloon swinging back and forth like a pendulum. The balloon is black, the background is black. We'll actually turn the lights out for you here. So there's no visual contrast. The idea is that there should be no way to see that balloon. The only difference between the balloon and the background should be thermal contrast. The balloon is warm, the background is relatively cool.
Handling a large python in the day requires great care. It's even more difficult in the dark. Michael covers the snake with a box until he's ready to start the experiment.
These snakes have lots of teeth, so if they bite you, you know it.
But for Michael, it's worth the risk. If the experiment works, the footage will be a world first.
So after the lights are off, we'll remove the box from the snake will be free, and hopefully we'll see some very interesting behavior. We'll learn something new about this amazing, unusual sensory system.
In the pitch black of the swamp at night, conventional vision is useless.
It's really dark. I can barely see to get this box off the snake. I'm afraid I might look like a warm balloon to this snake. We'll uncover the snake. It's a good thing we have this infrared camera. Otherwise, I'd have no idea where the snake is.
The sensitive infrared camera picks up the faint heat of the snake as a vivid orange and the warm balloon as a bright white.
Here he comes. Tongue flicking at it, moving his head with it. He definitely sees it. He definitely sees it. He's got eyes, but it is pitch black dark out here. So something else is telling him that that balloon is there. It is absolutely dark. It cannot be using its eyes, but it's following the motion of that balloon. It knows that balloon is there.
So how do these snakes sense a warm object in total darkness? The secret of the python's heat-seeking abilities lies in a series of tiny pit organs on their heads. A temperature-sensitive membrane lines the bottom of the pits. Any warm object emits infrared radiation, which passes through the air into the pits and warms the tissue by a fraction of a degree.
Thousands of tiny sensors in the pits detect these minute changes in temperature. The python has an array of these pits around its head, meaning the snake can track warm prey in total darkness. Pythons aren't the only snakes that hunt with heat. Pit vipers, such as rattlesnakes, copperheads, and the water moccasin, do too. They hunt at night. Even in the dark, they strike with pinpoint accuracy, injecting a lethal dose of venom with a single bite. Now, Michael wants to record one of these deadly snakes striking. This water moccasin's from his personal collection.
We've seen what pythons can do. They can sense a warm object, they can follow a warm object. The plan here is to show that the snake can really take it to the next step and make an accurate strike. This is a really dangerous snake. It's really dark out here. I'm afraid he can see me, but I certainly can't see him. So we're going to wear this headlamp and carry this just as an insurance policy. Lift the box off of our water moccasin. Let's see how he responds to this warm balloon. Right in front of the snake now. He's tongue flicking. He's definitely tongue flicking at it as soon as it got near him. Very interesting when you can't see a water moccasin that's right in front of you. Oh, I think he just struck it. I heard it more than I saw it. He got it. He definitely got the balloon. A couple of fang holes here. See the water squirting out? This is warm. I can feel it. But if this thing is even an inch away from my face, I would have no idea that this thing is there. I think he got a little surprised when he hit this target.
The camera caught all the action in astonishing detail.
Ah, look at this, look at this. Oh, that is fantastic. He's got the balloon, he struck it, he's pulling back. Look at that, you can even see his fangs have heated up because of the warm balloon. We know how snakes strike. We've even seen that in high-speed video before, but we've never seen this in the dark like this. We're literally watching, I believe for the very first time, the ability of these snakes to strike in complete darkness using nothing but this thermal imager.
This slow-motion footage shows the terrifying speed and accuracy of the snake's supersense.
Now, we counted the frames here, high-speed video, 120 frames per second. This strike took only 12 frames. That's only 0.1 seconds, a tenth of a second to make this strike, and the entire thing is over in a half second. If you think about it, he's got to judge distance, he's got to judge spatial location, and this is a moving object. It's not just something that's sitting there, and he does it all in complete darkness. I could watch this all night.
So, how do pit vipers like this water moccasin strike prey so accurately using heat alone? Just like the python, the secret lies in the tiny pit organs either side of their face. These pits work like eyes, except these eyes see heat rather than light. When infrared radiation enters the pit, it forms an image on the membrane. Nerves transmit the image to the same part of the brain that processes information from the snake's eyes. This means these snakes don't just sense where a heat source is, they see an image of the world in terms of heat. It's a fearsome super sense that makes these snakes lethal hunters, even in complete darkness.
We can feel heat, but we can't form an image of the thermal environment. What these snakes are doing is really completely different. They are literally forming an image in the brain. And we know this because as we watch the snake's behavior, they can very accurately target a warm moving object, even a small moving object, even a fast moving object. To me, this really represents a true animal superpower.
The snake's ability to sense heat gives it a formidable advantage when hunting prey in Florida's swamps. But to track down quarry in the vast ice-cold depths of the ocean takes a very different kind of superpower. One animal reigns supreme in this dark realm, a creature that has evolved one of the most remarkable super senses in the animal kingdom. The mighty sperm whale.
They hunt in total darkness, hundreds of meters beneath the surface of the sea. So, instead of using sight, sperm whales use sound to find and catch their prey.
So how do they do it? To find out, we must travel to a place where scientists study these mysterious. A tiny group of islands in the middle of the Atlantic Ocean, where unlike almost anywhere else in the world, sperm whales live all year round. The islands of the Azores.
Sperm whales are wonderful animals. It's like seeing a living submarine. Very slow, elegant, genteel, but you get a real sense of their power as well.
Ecologist Justin Hart is searching for whales in the Atlantic Ocean several kilometers off the coast of the Azores.
It's a great opportunity to see an animal that most people will never only see on the TV.
Justin is part of a global network of whale spotters and researchers. By pooling their data, they hope to learn more about these elusive animals. Today, Justin will investigate whether there are any whales at all in his patch. Just finding these giants isn't easy. Sperm whales spend 80% of their time deep underwater hunting. Because of their sheer size, they must catch about a ton of food every single day.
These animals have to eat a lot. Studies have shown, investigating their stomach contents, that a lot of the food they eat is squid, maybe only about this big. So obviously they've got to spend a lot of time eating a lot of those squid. Female sperm whales dive for like 45 minutes, male sperm whales well over an hour. And they do this continually, day in, day out.
The squid the sperm whales hunt live hundreds of meters beneath the surface of the sea. No light penetrates to such depths. So how do they catch so many squid in complete darkness? Sperm whales dive far deeper than us humans can cope with, so no one has ever actually seen them hunting. But one of their close relatives provides a clue.
We're in the Canal de Saint-Georges. All around us are common dolphins.
Dolphins can also hunt in complete darkness. And unlike sperm whales, they're happy to show us how they do it. In the warm waters of the Florida Keys, Pax the dolphin is about to attempt something incredible. He'll try to retrieve this ring from underwater while blindfolded.
Good job, buddy. This is what you're going to be looking for, okay? A nice big ring. And then I'm going to put the other eye cup on.
With these soft rubber cups covering his eyes, Pax can't see a thing. It's as if he's swimming in total darkness.
And then I'm going to throw this out into the environment, and I'm going to ask him to go get it.
Pax must now try and find the plastic ring. It seems impossible, but he knows he'll get a food reward if he's successful. And there's nothing more motivating than a bucket of fresh fish. Even without using his eyes, it takes Pax less than a minute to retrieve the ring. As he searches, he constantly makes strange clicking noises. Sperm whales make similar sounding clicks to help them hunt squid in the darkness of the deep ocean.
Initially, you just hear this steady click, 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 click. But if it detects something interesting in its environment, it might send out a faster click train.
These sonic clicks are the secret of the sperm whale's superpower. They're made up of short but very loud bursts of noise that we hear as clicks. Each click is actually a highly focused beam of sound firing out of the whale's nose.
The click travels at over 5,000 kilometers an hour away from the whale.
Any object in its path reflects the sound back. The quality of the sound tells the whale much about what the object is made of. And the length of time it takes for the echo to bounce back tells it how far away the object is. This sonar super sense is called echolocation.
Back on the boat, Justin still hasn't found any whales.
It's a big ocean out there. It's not always easy to find the whales and dolphins. If you go out there just with the boat, looking for them, there's a big chance you're not going to see anything at all.
But Justin's brought a special piece of kit that will help him track them even if they're hundreds of meters beneath the boat.
We've got a lot of wires and electrical devices in here which don't go well with seawater.
It's a special underwater microphone called a hydrophone.
I'm just connecting the amplifier on the hydrophone to the recording device.
Justin hopes this device will pick up the sound of the sperm whale's clicks.
I'm going to stick this in the water now and see if we can find these sperm whales. Okay, I can hear sperm whales. I can hear a steady click train. Just it's a very simple click, click, click. They're hunting squid and they're throwing out sonic clicks, testing the environment in front of them, testing the water, hoping something gets reflected back. All we can tell from this is that there's something within range of the hydrophone.
This is the sound of a true superpower. The sperm whale making this click could be up to 60 kilometers away. It's the loudest noise made by any animal on the planet. So how does the sperm whale make such a remarkable sound?
The sperm whale's strange clicks come from an organ inside its head, the melon. It's huge, the size of a family car, taking up nearly a third of its body. To generate the sound, the sperm whale forces air through a muscular valve at the front of its nose called the monkey lips. As the lips snap together, they make a loud click.
The sound from this click passes through a massive sac filled with a waxy substance. The sac acts like a lens, focusing the sound into a beam. Special reflectors near the sperm whale's skull bounce the sound back towards the nose and through more lenses, before it shoots directly out of the sperm whale's nose as a narrow beam. The whale's click is the loudest sound in the animal kingdom. It can travel through the ocean for up to 60 kilometers, enabling these giants to scan the ocean depths, hunting for signs of prey. In the Azores, Justin has been following the sperm whales, hunting deep beneath him by listening to the sound of their superpower. The whales are due to come up for air soon, but they don't always surface near the boat.
There it is there, right in front of us.
Amazing.
Okay, this is female sperma, Nikki. If you look at her dorsal fin, you'll see there's a small nick out of the top. It's now just finished its foraging dive. It's come back up for air. She's going to spend maybe 7 or 10 minutes now on the surface, reoxygenate the blood.
While the whales are on the surface, Justin's team gather as much data as they can.
Every time the sperm whale surface, I've been creating a waypoint on the GPS. We take a lot of data about the species, obviously. This is sort of a daily record of what we see, which provides some information about the daily and seasonal abundance of the different animals. We take photo identification shots, and they can tell us whether we're seeing the same individuals again and again, whether it's week after week, day after day, or even year after year.
Keep going. Just look in the water. She's right in front of you.
The whales don't just use their superpower to hunt, they also use it to investigate any strange objects in their environment, including humans.
The whale came back on me. I could hear it clicking.
Yeah.
Go click, 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 click,
We
click.
watched.
It was getting closer. I knew it was going to come. And it suddenly just came at me, straight at me.
They come over, investigate you, and you feel their sonar reverberating through your body, and then you know you're having a real experience with the animals.
You gotta swim now, you gotta swim. More to the left. More to the left.
Left.
More to the left. Hard, hard, hard.
This animal can sense the world in a way we can't imagine. I mean, it can enter the deep ocean, the abyss. It can explore undersea mountains and valleys, incredible places, places that we have to spend huge amounts of money to even get close to. It's a lucky, lucky animal.
The whales have recovered from their last dive. Soon they will descend into the depths once more, driven by their constant need for food. Although no one has ever filmed a sperm whale hunting, scientists have followed them another way. The whale's tough skin and blubber are up to 35 centimeters thick. So without causing the whales any distress, researchers at Oregon State University attached specially designed GPS trackers directly to the whale's hide.
The tags enabled the researchers to track several whales in the same social group. What they found astonished them. The three whales dive down together in search of squid.
Two whales, and probably the rest of their social group, stay at a certain depth. But one dives far deeper.
Researchers think it is either driving squid up from the depths into the jaws of its companions, or acting as a guard to stop the squid from escaping. Either way, it seems the whales are working together. They are showing signs of intelligence and cooperation.
The sperm whale's ability to see with sound is one of the most powerful super senses in the animal kingdom. But much of their lives remains mysterious. Thanks to researchers like Justin, maybe one day we'll know more about these magnificent creatures.
We know more about the surface of the moon than we know about the deep ocean. And so the sperm whale is like a window into that habitat, that environment. It goes places we can't. And for that reason, it's an animal of great mystery to us. And to be able to learn more about this animal and see something of its life and how it sees the world, I think that would be very interesting indeed.
Some think superpowers only exist in the movies, but these hunters really do possess powers we humans can only dream of.
Now the sharks can hunt at night, they can hunt under very murky conditions, whatever. They don't need to see their prey, and that really contributes to their success.
Fascinating animals, elegant, genteel, living submarines.
To me, this really represents a true animal superpower. There is literally nothing else like this on the face of this planet.
The sperm whale, snake, and hammerhead shark each has evolved a super sense. Seeing heat, sensing electricity, and seeing with sound. It makes them deadly, even in the dark. But there's much we've still to learn about nature's greatest hunters and their mysterious animal superpowers.